I'm Angela. I did frame for Catmobile. If you guys have any questions as we go along, ask them. I hate trying to have you hold questions to the end because I always forget them. So if you have anything, put your hand up. Kind of an outline for everything is starting out. We had the idea that we obviously wanted to frame under the shell. We've had the shell for, I want to say, 4, 5, 6 years. MET students built it. It's just kind of sat around and gathered dust quite a while. And the idea to build a frame and go under it has been in the books for a couple of years and it's kind of never really gone anywhere. The other plan was also the electric vehicle club is trying to get up and going, so we wanted another car to race. I have footage of our race from the PIR that I'll show you guys here in a little bit to give you an idea of how everything goes. Starting out, the frame basically was designed how you see it, except for it had more supporting members. Basically, safety was the biggest thing in this, especially when you're going 50, 60 miles an hour in a car that weighs a couple hundred pounds of everything. So it started out over the top, and slowly we reduced members until we got to a point where we thought it would actually be sturdy and rigid enough to support both a human driver in Dallas at 180 pounds, and you got 2 batteries that weigh 73 pounds, battery controller, 3 wheels, steering wheel, braking components. So we wanted to start somewhere. Couple things that came into it is the hoop on this. The hoop on here, we had another student build, and he treated to bend it. So the idea was that that hoop wasn't strong enough because of a rollover. When you're sitting in the vehicle, your helmet has to be, and your head have to be under the hoop, so right down in here. And we thought maybe if he treated weaker material, so we went through and actually rebuilt the hoop and rebent it. But to bend it with that narrow of a diameter bend, we actually had, I made with the help of a lot of people for advanced machine, I built an apparatus to bend the hoop, which I'll show you pictures of here in a minute. Starting out, we didn't know where we wanted to go. Obviously, we had the shell, it was carbon fiber. We had to build a frame. We didn't know if we wanted to do square tubing, round tubing, rectangular tubing. Ultimately, when it came to bending the hoop, we knew we wanted to do round tubing because that would be the easiest. So that's how that started out. To take measurements before anything went in after hand sketching, me and Charles sat down and went through everything, basically all the components, figuring out where everything was going to be. We already had a template of where the hoop was under the bulkhead. That made it easier, especially when doing all the bending and making everything fit perfectly. Went through, bolted everything up. The front of the car actually bolts right at the front of this member, which makes it nice because we can pin through, bolt the front end onto that. Everything fit really, really well, almost. With Electrify America, who basically sponsors all the Electrify races, there's a lot of safety regulations that go into it. 5-point harnesses, ballast weights. You have to be able to hold the brakes, be pushed on a certain force so that you don't roll forward, obviously, once again for safety regulations. And we had a lot of different design requirements where we wanted to have batteries, motor controller, where we wanted to have steering, everything like that. The other part of the project that opens up, and you guys will probably see this next year, is hopefully students run with this and they use this for their senior projects. So you have students doing braking designs, steering designs, wheel placement, axle placement. Hopefully that takes off and you have students working with it next year and kind of opens the door. Wheel configuration obviously is already set out because of the shell. You've got 2 wheels up front, 1 in the back. So I really didn't have much say in that. This is what I made in advanced machining. Kind of was a byproduct to bend the hoop. To make it fit under the bulkhead, like I said before, I had to have a 6-inch diameter bend. With that thin wall tubing, it's 065 wall, 1020 tubing, steel, mild steel. So it was really wanted to basically bend, crack, everything else. So we took a piece of 4-inch tubing, packed it with sand, capital things, and put it around this apparatus. So I have a picture of it coming up. To make it so that it would bend without actually buckling. I said before, when I started with SolidWorks, we had a lot of original members. Everything on this was actually individual pieces. Now the top is all one piece here, the bottom is all one piece. I actually started individual members. There was bracing members, basically everywhere. And so slowly we started out with a sketch and a design in SolidWorks, and slowly members got deleted. Slowly members became joints. Slowly everything kind of changed around. Piece by piece, it went through the process. Here's Ted. A lot of help from Ted Sweeney and Brendan for actually making this. I worked with some modeling in 355, but I haven't worked with a lot, so I didn't know Mastercam like the back of my hand like Brendan does. So he helped me out a lot with the modeling and building of this and actually running everything with the mills. Ted, Chris did a lot of help, and we got another couple guys to bend this tubing around the bridge board. We bolted it down. How it works is we bolt it down to the bridge board, put a piece of steel tubing in with the pulley all the way out, and basically pulled the lever around the dowel we made. That was 6-inch diameter to bend the tube around the top. We had me, Ted actually bent it. Me and Chris held the bridge board, and we grabbed another couple guys because I actually wanted to turn the bridge board around because there's so much force involved actually bending it over, which also increases the strength of the top, which is what we're going for. Starting out, I basically put everything together, tackled everything up, how we finally got everything ideally made up in SolidWorks. Put it all together, brought it over, put it under the shell, and it ended up being too tall. It was actually 2 inches too tall, which is how I modeled it. Just ideas within how everyone thought it should be were different. So we went back, with Ted's help, I pulled it all apart, cut 2 inches off all the members, shortened it so that it actually fits smooth underneath the shell now. It's on the ground when the shell's on the ground. And then I brought it back over to PowerTech, re-welded everything up, tack welding it, brought it back over, tested it again for the second time. Everything looked good. I got to go ahead, welded everything up with Matt Kirby's help, and then brought it back over, tested it with it welded up. Everything fit, once again, everything fit perfect, so we went with it. For testing, I originally wanted to start with just deflection. You have whatever the driver weighs, and then you have a ballast weight, so you have to end up being 180 pounds. So originally I wanted to do deflection in the center because the person's going to be sitting there, your feet are going to be running down. I figured I'd put weight right in the center. Professor Prino actually changed it around so we have most of the weight during testing right here. Obviously, thanks John. I have all my weights lined up. Played Django for a while until I get it right. And all my weight testing in increments, 60 pounds, 60, 120, 180 pounds. 120 pounds, I had 1/1500 of an inch deflection, which is actually better than I thought I was going to have. I actually calculated for a 1/4 inch deflection. That again could be because I did all the way here instead of actually in the center of the frame. So there's a little play there. While I was at it, I actually applied strain gauges as well, just to see where, what members were under the most strain when under load. It actually came out that the hoop was under the most strain, probably because of all the bends and maybe a little bit of how I had the gauges set up on it as well. The top member was under no strain, columns were under no strain at all, basically all the way up to 180 pounds. And then what I didn't foresee happening is actually, with weight on it, these two columns actually bowed down and put the strain gauges in compression, whereas this one actually bowed up and put the strain gauge in tension, which I didn't actually see for. And once again, I thought I was originally doing testing here, figured everything would basically bow down, and that could have been a some of it as well. Like I already talked about, unexpected problems. Didn't know that with how everyone agreed on stuff that I was going to actually have to cut 2 inches off each member. Strain testing, I actually originally wanted to do 6 gauges. I ended up doing about 16, so a little bit more there. And also taking everything apart, we had to grind everything down, remill most of the pieces, just time added up. I was already at probably 300 hours when it came to actual construction, solid modeling, brainstorming, everything else. And then by that point, I actually had to go back, and that was literally at the end, when a quarter that we decided on that. So big hand to Ted because he actually helped me a lot over a 2-day period. We put about 24 hours in. Basically, we did everything, we welded everything up. I'm a big hand to Bertie for helping me weld everything up. Like I said, unexpected problems, shop times. I was in the shop a lot, me, Brendan, the guys, hanging out basically for long hours, buying dinner at 9 o'clock at night, hanging out. Didn't foresee that coming. Let's see if I got a video of that to show you guys one of that. Project overall in conclusion was a lot larger than I expected. I have done a little bit of welding before, one of the members. I never really took into consideration the fact that everything on this would have to be more precise than I've done before. I take this stuff welded together, call it good. When you take into consideration that everything has to be milled down to almost exact, trying to keep everything flat, even make it available for next year's students to actually be able to mount things and not be like, well, this is a 1/4 inch off, this is wrong, this is wrong. That actually took a lot more time than I had figured. Once again, big hands of resources. Thanks to Roger Beardsley, Charles Springwell, Matt Burby, Deb Bramble, Chris, and Brandon. Here's a video that I have, and I think it'll play. This is last week in PIR. Just kind of gives you guys an idea of. We had 50 different cars racing in PIR. So, and it's close quarters, so you have to kind of have an idea of where safety comes into large regulation here. There's actually a point, literally first lap of every race, someone hits someone else, crashed them off. No joke. First lap, there's 4 different races over the 2 days, 2 each day, and someone rides first lap and show. There's actually a wall coming up where someone hit dead on more than 40 miles an hour. Didn't account for it. He had front wheel steering, the wheels kind of went their own way, and he went dead into a row of tires at 40 miles an hour. So once again, that comes into safety with the helmets, everything. There's a guy off the course, up to the left. He went off the track, his wheel went flat, and he just went off the track. So if you guys have any questions, you know I said that, so I'm going along.